how to simplify rational expressions, harder kinds, coming up. Back into action, episode 2. Hey guys, and this is episode 2 on simplifying rational expressions or algebraic fractions. So we need to get them down into simplest form possible. So as far as we can, as much as we can. Or sometimes it's said we need to reduce it to its lowest term. It's precisely the same. If you have no clue what I'm talking about, but you need to know and it's important for you, please check out my first episode on how to simplify rational expressions, where I came up with two kind of simplest examples, and I explained actually steps or pattern that you should follow, and also I came up with the idea of excluded values or restriction or condition that might come in. Now, put in a nutshell, there are 3 steps to be followed. The first step, you factor as much as you can. You factor top of your fraction, and you factor bottom of your fraction. So sometimes you cannot, sometimes you can, but the point is you have to factorize, do factoring as much as you can. After factoring, hopefully something that called common factors might pop out at you, so and you could cancel. And the last step, it's not actually that mandatory, it's not that a must, you have to do. And in my first episode, I literally gave a lecture about this, and it's excluded values. It's basically the values of x. They would have made your denominator undefined. They would have made your denominator equal to 0. So that values actually create that 0 problems that might come up, that might pop out in your problem. It's not always, but sometimes yes. And about excluded values, it's optional, as I said. It depends on if you're asked to do this. Alright, let's get the first one. Well, start with the top. Since you have x squared minus 3x, these two terms, they have a common factor, which is x. Take it out, pull it out. What's left behind? What goes inside your parentheses? Instead of x squared, you would have just x, and you had 3. Again, at this stage, I always suggest you to check it out mentally. You don't have to write, just do it in your head. It's not that much, but you will be safe. It's better safe than sorry. So just x times x gives you x squared back, and x times negative 3 gives you negative 3x. So at this point, you are fine. Moving on. Look at the bottom. Actually, it's a standard classic quadratic. So, and actually it's factorable. So you could break it up into 2 factors, 2 sets of parentheses, both starting with x, the variable you are given, and you need to come up with 2 numbers that actually could be filled into these 2 gaps, into these 2 holes. I have a separate video on factoring quadratic. It's actually called solving quadratic equations by factoring. Also, there is another episode by using a special technique which is called magic X, but that idea also applies here at this point. So it's totally fine, and actually you have to use it. So if you are not that confident about this stuff, just please check out my other videos on this. Now, in a nutshell, so you're looking for 2 numbers, and these 2 numbers, their product gets to negative 3, and they add up to the middle coefficient, which is actually negative 2. So their product is negative 3, and their sum is negative 2. So the numbers, they're going to be negative 3 and 1. So again, you can check out their product. Minus 3 times 1 gives you minus 3. Minus 3 plus 1 gives you minus 2. Also at this stage, you can just simply FOIL out and multiply things out, and you would come up with the original standard trinomial. So you are fine. Now check to see if your top and bottom have a common factor that can be cancelled out, cancelled off. So yes, you have x minus 3 on top, and you have the same x minus 3 on bottom. Now these excluded values come out. So excluded values, these values of x or other variable that you are given, that create this division problem. So when you simplify, you would end up with x over just x plus 1. And from here, you would have your x minus 3 cannot be equal 0. That implies that your x actually is not equal to 3. So, and again, this is your excluded value. Why? Because when you plug in x equals 3 over here, there is no problem. You will be left with 3 over 4, since 3 plus 1 is 4. But when you plug in your 3 over there or over there, so your denominator gets to 0. Your denominator becomes 0. So your algebraic fraction is undefined. So your algebraic fraction has no algebraic meaning. So that's why this restriction has to be imposed on your rational expression. Again, as I said, it's optional, and sometimes if you are not asked, just ignore me at this point. Moving on. You have one classic quadratic on top and you have another quadratic on bottom. So there is no overall term, overall constant that can be taken out, that can be pulled out like we did the first one, like was x, or it could be a constant. So there is nothing like this, so nothing can be pulled out, no overall term or constant. So you need another approach, you need another technique to be used at this point. So since you have quadratic, try to factor it out. So since your first coefficient is not 1, it's not like we did over there, so there is a magic X, which is another special technique for factoring, for factorizing quadratic expression, and you can check it out. Now, basically, if you would have your quadratic breaks up into two sets of parentheses. The first one is going to be 2x plus 1, and the second one is going to be x plus 3. Check to see if we are right. So 2x times x gives you 2x squared. 2x times 3 gives you 6x, plus x gives you 7x, and 1 times 3 gives you 3. So your top expression can be broken down into these two sets of parentheses. We are done with factoring within top. Moving to the bottom. Look, you have overall constant, which is 2, that can be factored out first. 2 can be taken out and placed outside of your parentheses. What's going inside? You would be left with just x squared plus 2x minus 3. Now things getting better. So at this point you just rewrite your top as is. Just now there is nothing to do with your top. And for bottom, you could use factoring as well, since you have quadratic. So this is normal factoring, this is not magic X, this is a little bit tricky, a little bit more harder, I would say. It's like very similar what we did in number one. So you need to come up with two numbers that they multiply to the last number, which is basically -3, and they add up. Their sum gets to the middle number. So they multiply to -3 and they add up, they sum up, they tot up to the middle number, which is 2. So you could just think of these numbers, and it's gonna be 3 and -1. Again, check to see at this stage. No harm in just checking out. 3 times -1 gives you -3 there, product, and 3 minus 1 gives you +2. We are done with factoring. We completed with factoring. So we factor out within top and within bottom completely, totally. Now, moving to the next step that says cancel. Cancel a common factors that belong to your top and to your bottom. So spot any common factors that your top and bottom might contain. So as you can see, x plus 3 goes on top and x plus 3 is on bottom. So cancel it. Just delete it, erase it, cross it out, and we are left with just 2x plus 1 on top, and still keep this 2, do not lose it, 2x minus 1 on bottom. Again, at this point, check to see if any more simplifying can be done. Since no more simplifying can be done, this is your final simplest version for that factoring problem, that rational problem. But again, if you ask for state the excluded values, so as soon as you cancel x plus 3, this x plus 3 would create your division problem. So you take this x plus 3 and you set it not equal to 0. So this is your, after solving this kind of equation, you would come up with your excluded values. So from here you would end up with x cannot be equal -3. So x is not equal -3. And again, at this point, it's not that obvious, right? It's not that obvious, because if you plug in -3, the -3 over there to the final answer, there is no problems. It's totally fine, it's totally valid. But when you plug in your -3 over there, or in your also original expression, because they're equivalent, so your denominator becomes 0. So this -3 would have made your denominator undefined. That would have made your denominator equal to 0. So your entire whole algebraic fraction has no meaning at this point. Well, we're done for today, but we're not done with rational expressions. It's a huge topic actually. And I have the third episode where I come up with operations on algebraic expressions such as addition, subtraction, multiplication, and division. So if you're up to this, please check out my episode 3. Well, I hope it helps you guys and train your brain, and thanks for watching. I know everyone hates maths, but if you like my video, please hit like button, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss my new videos.